Hi there. And we are back with this week's Math Monday. As you recall, in week number 1, we went ahead and we made and launched air-powered rockets, not only because it was fun, but also to collect some data that then we could use to really learn some real math concepts, including finding landmarks in data. Last time, we worked on what I called bell pepper level landmarks. This was minimum, maximum, and range. It is mild, it is accessible to everyone. Today we're taking the heat and turning it up just a little bit to a Poblano level math problem. Now, on the Scoville pepper heat scale, Poblanos tend to be anywhere from 1,000 to 1,500 Scovilles. Now, 1,000 is a big number, and that sounds like a lot, but considering that the Scoville heat scale has a theoretical top end of 16 million, 1,000 or 1,500 isn't very much. So there is some mild heat here, and this math is accessible to almost everyone. So today we're going to be looking at median and mode. Go ahead and get out your rocket data analysis sheet if you have not done so already. And then we will meet back in just a moment to learn what median and mode are and how to find them. And we're back. So we're going to start with mode. The mode of a set of data is the most common or the most popular number. It's the number that occurs most often in your set of data. Now, some data sets don't have a mode. If I only had 3 numbers for my rocket flight distances and they were all different, then I wouldn't have any number that occurred more than once, so it's possible for a data set not to have a mode. On the other hand, it's also possible for a data set to have 2 modes. It's possible that I would have had 2 rocket flights that were 8 feet and 2 that were 15 feet, and then I would have 2 modes. This would be called bimodal. Bi, of course, means 2. You also see this prefix in the word bicycle, meaning 2 wheels, or bicentennial, meaning 2 groups of 100, or even biped, meaning 2 feet. Now, when we look at our data set for rocket flight number 1, we can see that I have, it looks like I'm counting the 13s, only one 13. Let's see, it seems that I have several 11s. Let's see, I have 1, 2, 3 11s. I'll keep checking. Let's see, I only have 1 9. I have 2 10s. Let's see, do I have anything more than 3? It doesn't look like it. So it looks like since I have 3 rocket flights that were all 11 feet, then 11 would be my mode for data set number 1. I'll write that in here. Data set number 2 is different, of course. I'll have to look through there. Let's see, I've got 13, 13, 13. So I've got 3 13s. I'll keep that in mind. Let's see, 1, 2 14s. That's not as many as 3. 15, 15. I also have 2 of those. Looks like I've only got 1 17, an 18, and a 19. So in data set number 2, it does appear that 13 is my most popular number, my most frequently occurring bit of data. So I'll put in a 13 there for the mode. Next, we're on to the other landmark for today, and that is median. Median is a word that means the middle, and you can remember that because in the center of the road, in many roads, there's that little strip of concrete where people plant crummy trees and flowers, and we call that the median. It's the center of the road, and the median is the center number in the data set. But it's only the center number once you've lined up the data from least to greatest. This is a critical step. If I were to just take my data here and just pick out which number was the middle, this wouldn't work at all because it's not lined up yet. So I'm going to take a minute and line up my data. And I'm going to go from least to greatest. Let's see, I've got 8 is my minimum, 8. And I'm going to separate my math numbers with commas. I'm separating my math ideas with commas, and that's the same thing I do in literacy. When you have a series of items or a list in a sentence, you do separate those ideas with commas. I'm doing the same with math. So let's see, I've got an 8, and I've got a 9. And I'm going to put a big dot over here as I've used these numbers to make sure that I've got them all and to make sure I don't accidentally use any twice. Let's see, and I've got 1, 2 10s, 10, 10. And I've got some 11s, and we determined 11 was the mode. So I know I've got 1, 2, 3 11s. So I'll list it 3 times. 11, 11, 11. And let's see, I've got 1 12. And I've got a 13. And I've got a 14. So I'm looking over my list. I've got a dot next to every one. I'm making sure that every number is accounted for. But now I'm going to double check another way. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 rocket flights. And then I'm going to check my ordered list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have all my data accounted for. Excellent. So now I'm ready to find the middle number. One of the most common ways that people do this is you can start at the bottom and the top and simply cross off a number from the bottom, the top, the bottom, the top, the bottom, and the top until you find the number that's in the middle. I'll do that now. I'll cross off the minimum and maximum, and then the new minimum and the new maximum, the new minimum, the new maximum, the new minimum, the new maximum, and then I'm stuck. Because if I cross out the next 2 numbers, then I don't have any numbers left. Sometimes you have to deal with this when you're finding median. That when you have just 2 numbers left, as we do here, you have to find the middle, or the median, of both of those 2 numbers. Now, in this case, this is pretty straightforward because both of my numbers are the same. So the middle between 11 and 11 is simply 11, and there is my median. Now I'm going to do this again over on my second set of rocket data to see if I'll end up with a different median and to let you know what you have to do if you come across this situation. So once again, I'm going to order these numbers from least to greatest. It looks like I've got 3 13s. 13, 13, 13. I'll put dots by those. Looks like I've got 1, 2 14s, 14, 14, and now I've got 2 15s, 15, 15, and I don't see any 16s. I do, however, see a 17, an 18, and a 19. So that rounds things out. 17, 18, 19. Now that I'm here, once again, I'm going to cross off bottom, top, until I find a middle number, and I'm left with 2 numbers, and then we'll talk about what to do next. Bottom, top, bottom, top, bottom, top, bottom, top. Once again, I am left with 2 numbers, and in this case, the 2 numbers I'm left with are 14 and 15. So I have to find the middle between 14 and 15. Now this isn't too challenging. You might say to yourself, well, if I had $14 and my brother had $15 and we had to kind of even it up so we both had the same amount, we'd find the middle value between 14 and 15. So that would be $14.50 in this case. You could also, of course, write that as a fraction, 14.5. Now let's say I had 2 unusual numbers there that I couldn't just fall back on my background knowledge about how American currency works. Let's say I had 17 and 20 there. Well, in this case, I don't happen to know what the middle between 17 and 20 is, so I'm going to have to find the difference between the 2 numbers. As we know, the word difference is associated with subtraction. So the difference between 17 and 20 is 3. So if I know the distance between here is 3, and each number has to give up half of that, I could simply find half of 3. I happen to know what half of 3 is, as I've had to divide up $3 a couple of times. But in case I didn't, I'm going to go ahead and I'm going to have to use a relatively tricky math operation. I'm going to have to use division. that I could take 3 and I could divide it into 2 pieces in order to find how big each piece is. Let's see. 2 goes into 3 once. 1 times 2 is 2. I subtract, my difference is 1, and I'm finished with my calculation. That's a pretty straightforward division problem. So I have a whole unit and then 1/2 of another unit, or 1 and 1/2. So halfway between 17 and 20 is worth 1.5. So I'll take my 1.5, add it to 17 to get my median, or my middle, of 18.5. Naturally, in a data set where the numbers are a lot bigger, or it features fractions or decimals, this calculation can be much, much more complicated. You might take this relatively mild, a poblano level math idea, and this could easily be turned up to a habanero kind of pepper level if you were trying to divide fractions, say, or decimals with places out to the hundredths or thousandths place. So these ideas are straightforward, and the techniques will be useful for more complicated numbers, but you should keep in mind not every data set you ever come across will have nice friendly numbers like this. In fact, in the real world, most data sets don't. Well, that's all for this week, and I'm looking forward to seeing you next week